नमस्कार दोस्तों, मैं आज आपको जेके फ्लिप फ्लॉप बताने जा रही हूँ। जेके फ्लिप फ्लॉप जो है इट इज अ sequential bistable memory device, and if I draw the diagram, like for example, I have 4 NAND gates here, right? And here is a cross connection of the last 2 NAND gates, and here we apply the same clock input to these 2 NAND gates. Here we apply J input, here we apply K input, right? And then what is the circuit diagram here? That it is the modification of SR flip flop. Okay, so here if this is your Q and this is your Q bar output, and here it is this. Okay, now see here 1 2 3 4. Okay, now see here what happens. We have to draw the truth table of this JK flip flop because it is a modification of the SR flip flop, as SR flip flop has many advantages, but it has one disadvantage, that when S is equal to R is equal to 1, there is a race around condition. Okay, that means it suffers from uncertainty in the output. So this problem is solved by converting SR flip flop into JK flip flop, right? Now here when I draw the truth table of JK flip flop, like here it is J, it is K, and here it is Q n plus 1. So here if J and K are 0 0, then here what will happen? The next state will have only memory in it. That means the past information that will be stored here, it will directly come to the next state. So if, for example, if clock pulse is there, if you apply here 0, or whatever you feed the input at J and K, they will be, the output will have no change. Okay, if you apply clock 0, then output will have no change. Again, if you apply here clock 1, the output will have no change if J and K are 0. If clock is 1 and J is 1 and K is 0, then what will be Qn plus 1? Let me suppose here, if J is equal to 1 and K is equal to 0 and clock is 1, and we don't know the outputs. So let Q is equal to 1 and Q bar is equal to 0. So here Q is equal to 1 is transferred to K, and and Q bar equal to 0 is transferred to J input. So 1 dot 0 is 0, and here the inverted output will be 1, and here it is 0, it will be 1 here. So 1 here it is passed, and here 1 it is passed. So here what is happening here? There is a cross connection. So Q is equal to 1 here, it is transferred here, and Q bar 0 will be transferred here. So 1 0 is a 0, in the inverted output will be 1, 1 1 ja 1, the inverted output will be 0. That means we are getting Q is equal to 1, Q bar equal to 0. Okay, so it means when J is equal to 1, K equal to 0, so the output will have Q is equal to 1. So this J is acting as a set and K is acting as a reset pin. Now again, when clock is 1, J is 0 and K is 1, then what will happen? Now we have to just check the table. Okay, now here it is Q is equal to 1, and you are applying J is equal to 0 and K is equal to 1, right? Now just what I'm doing, I'm just erasing the previous inputs so that you may have no uh, query. Okay, you can easily understand. Now here, see, now Q is equal to 1 and Q bar is equal to 0 here. Now this Q is equal to 1, again it is transferred to here. If I apply the previous output, and here Q is bar equal to 0, so it is 0. So 0 0 is a 0, it is 1, and it is 1 1 ja 1, so it is 0. So this 1 is transferred here, this 0 is transferred here. Now what is happening here? This 0 is here and this 1 is here. So 1 0 is a 0, here it is 1, and here 1 0 it is 1. So see what is happening here. What we have to do, you have to assume it actually, because we are not getting it like this way. Let Q is equal to 0 and Q bar is equal to 1 in case when clock is equal to 1, J is equal to 0 and K is equal to 1. So what will happen here? When J is equal to, here we apply Q equal to 0 and Q bar is equal to 1. So this Q bar is equal to 1, it is transferred here, and here this this is q equal to 0. So this q equal to 0, here it is gone like this way, and this one is like this way, and here 0 zeros are it is 1, so it is transferred here. So 1 zeros are 0, it is 1 here, and it is 0 1 just 0, so it is again 1 here. Now this one is transferred here, and this one is transferred here, so it is 0. No, something is lagging. 1 minute. What I am doing here, what you have to do, see, what you are doing, you are just assuming, okay, when q is equal to 0 and q bar is equal to 1, so this one is transferred here, and this 0, this, sorry, this 0 will be transferred here, and 1 zeros are 0, it is 1. If it is 1, it is going to transfer like this way, so it is 0, and here it is 1, it is 1, so 1 1 ja 1, it is 0, and here 0 1 ja 0, it is 1, right? So here again we are getting the output like this way. Now if here clock is 1 and j and k are 1, what we are doing, clock is 1 and j is equal to 1, k is equal to 1, so what will happen, this qn plus 1 will be the complement of qn bar. Let q is equal to 0 and q bar is equal to 1. Now as you can see from this, what it is happening, if I just take the marker, choose the marker, and here I write here j is equal to 1 and k is equal to 1 and q is equal to, it is 0. So here it is 0, it is coming, and q bar is 1, so it is coming like this way. So 1 1 ja 1, it is 0, and 1 zeros are 0, it is 1. Now this 1 is transferred here, this 0 is transferred here. Now again, this is what, this is q bar is equal to 1, so this one is here, 0 1 ja 0, it is 1, and here this 1 comes, 1 1 ja 0, it is 1. Actually it should be the toggle. If it is q is equal to 0, again revise it 0, and here this q is equal to 0, it is like this way, okay, and this q bar is equal to 1, this is like this way, 1 1 ja 1, it is 0, and a 1 0 ja 1, it is 0, so this is 1, this is 0, and now here it is 1, this is 1 0 1 ja 0 1, and this is 1 comes here, 1 1 ja 1, it is 0, it is 0, sorry. So here q is if q is equal to 1, q bar is equal to, that means it is complementing state. So this is 0 and this is qn bar, right? So this is the truth table of JK flip-flop. You have to assume it. Every time you just choose Q is equal to, now you choose Q equal to 1, Q equal to 1, Q bar equal to 0, then you will again get the complemented outputs, right? So this is the JK flip-flop. Now what you are going to do, if I just make clock JK flip-flop like this way, and here I just feed the same input, so this is like SA. This is your clocked JK flip-flop. It is what? This is your clocked JK flip-flop, right? And here it is J, K, Q, Q bar. This is your clock input. This is the logic symbol of JK, okay? So here it is. what I'm going to make, I'm making just characteristic equation. I have already told you the truth table. Now I have to make the characteristic equation, and according to it, characteristic equation will come into play when I draw the characteristic table, and characteristic table comes from the truth table. Okay, in characteristic table, whatever we take it as you can see, this is clock JK flip flop, right? Here, these are the four NAND gates. Okay, now what here I have applied one more AND gate. This, okay, this is like this way, and earlier it was, why it is said to be clock JK flip flop. Clock JK flip flop because clock is also applied there, no? So uh, it means it is just multiplying the input. Okay, it is just multiplying the input. Like this is Q, so it comes here Q. Here we get KQ, and then here clock. Then here it is KQ and clock bar. Okay, again here it is Q bar, so it is JQ bar, it is feeding, and this is your clock pulse, and then it is JQ bar dot clock, and here it is bar. So again it is feeding like this way. So this is the clock JK flip flop, right? Okay. Now for the characteristic table, what I have to do, I have to take three inputs Qn, J, and K. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. Now here you have next state. Okay. Now what is the truth table here? 0, 0, 0, 1, 1, 0, 1, 1. So here it is Qn. Okay. Qn plus 1 is Qn. So uh, and it is Qn bar. Okay, so when you apply here 0 0, so it what it will become, it will be Qn only. That means the previous value. That means if it is uh, then 0 1, it will be 0, then 1 0, it will be 1, then 1 1, it will be toggling. That means it will be the toggle of Qn. It will be 1 here, right? Now again here when it is 0 0, then it will have 1. Then again if it is 0 1, it will have 0. Then again it will 1 0, it will have 1 because it is set a pin. When it is 1 1, it will be toggle of the previous value. Now what I have to do, I have to draw the K map. In this K map, what will I take? I will take this Qn as one input and Jk as two inputs, 0, 1, 3, 2. As you can see here, it is 0 0. So I just take the previous value as 0. So it is 0 0 1 1, and it is uh, 1 0 0 1, right? And then it is 0 0 0 1 1 1 1 0 0 1. J bar, K bar, J bar K, JK, JK bar, and it is Qn bar, Qn. Okay, so this is like this way, this is like this way, and what you have to do here, no, you can also do like this with this and this. Just forget this. It will be like you. What will you get here? Next state K map equation. It is like it will be J Qn bar and plus it is Qn of K bar, right? This is your characteristic equation which comes from the characteristic table. In the characteristic table, we just apply the three present inputs K, Q, and JK, and we derive the next state. Okay, so now what is going to happen? I have to draw the excitation table. Okay, see that I have told you. अभी इतना ही करो, एक्साइटेशन टेबल नेक्स्ट क्लास में। टिल देन इसको लाइक शेयर सब्सक्राइब करना मत भूलिएगा। थैंक यू।